Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic that's absolutely critical for our future, but one that doesn't get nearly enough attention. We all talk about solar panels, wind turbines, and electric cars as the heroes of our green energy transition. They're the symbols of a cleaner, more sustainable world. But what if I told you that the very heart of these technologies relies on a group of mysterious and sometimes problematic materials? And what if the supply of these materials is a ticking time bomb? That's right, we're talking about rare earth elements, or REEs. The name itself sounds like something out of a sci-fi movie, doesn't it? But these elements are very real, and they are the unsung, indispensable components of our modern world. Without them, the smartphone in your pocket wouldn't be nearly as smart. The screen you're watching this on wouldn't be as vibrant, and critically, our dream of a world powered by renewable energy might just remain a dream. So, what exactly are these magical ingredients? Rare earth elements are a group of 17 chemically similar metallic elements. Despite their name, they aren't all that rare in terms of their abundance in the Earth's crust. Some, like cerium, are actually more common than copper. The real challenge, and the reason for their name, is that they are rarely found in concentrations high enough to make mining them economically viable. They're scattered, diffuse, and often mixed with other minerals, making their extraction a complex and costly process. Now, why are they so important for green technology? Let's take a look. Think about a giant wind turbine, its blades gracefully turning in the breeze, generating clean electricity. The powerful magnets inside the generator that make this possible are often made with an area called neodymium. These neodymium magnets are incredibly strong for their size and weight, which allows for lighter, more efficient, and more powerful turbines. Without them, turbines would have to be much larger and more cumbersome to produce the same amount of energy, making them less practical and more expensive. It's a similar story with electric vehicles. The high-performance electric motors that give EVs their impressive acceleration and efficiency rely on these same powerful neodymium magnets. They are the secret sauce that makes electric motors a viable alternative to the internal combustion engine. And what about solar panels? The very things that capture sunlight and turn it into electricity. Many advanced, high-efficiency solar cells use elements like indium and tellurium. While not technically rare earths, they fall into a similar category of critical materials that are essential for renewable tech. These elements help to create the thin films that are exceptionally good at converting photons from the sun into electrons that can power our homes. The push for more efficient and powerful solar panels is driving up the demand for these specific materials. But the story doesn't stop with green energy. Rare earth elements are everywhere. Terbium and europium are used to create the vivid reds and greens on your TV and smartphone screens. Lanthanum is used in camera lenses to reduce distortion. Gadolinium is a contrast agent used in MRI scans, helping doctors see what's happening inside our bodies. From the hard drives that store our data to the fiber optic cables that connect us to the internet, REEs are the invisible backbone of our 21st century lives. They are quite simply the elements of technology. So we have these amazing materials that are enabling our transition to a cleaner future, empowering our digital world. What's the problem? Well, here's where the plot thickens. The demand for these elements is skyrocketing. As the world races to meet climate goals and move away from fossil fuels, we need to build an unprecedented number of solar panels, wind turbines, and electric cars. A recent and frankly quite alarming study laid out the scale of the challenge. To meet our global climate targets and satisfy the growing demand for renewable technologies, the production of some of these key elements like neodymium and terbium needs to increase dramatically. We're not talking about a small bump here. The study concluded that we would need to mine and produce up to 12 times more of these materials by the year 2050 than we do today. 12 times. That is a staggering increase. Think about that for a moment. It means that in less than 30 years, we need to find, extract, and process an amount of these elements that dwarfs everything we've done in human history. This raises a huge and very uncomfortable question. Can we actually do it? And perhaps more importantly, what will be the cost? This brings us to the dark side of rare earth elements. The process of getting them out of the ground is anything but clean. Remember how I said they are rarely found in concentrated deposits? To extract them, miners have to move massive amounts of earth. The ore is then subjected to a series of chemical processes, often involving harsh acids and other toxic substances, to separate the valuable elements from the waste rock. This process can be devastating for the environment. It can lead to widespread ecosystem damage and soil erosion. Worse still, the waste products, known as tailings, can be a toxic stew. The ores that contain rare earths often contain radioactive elements as well, like thorium and uranium. When the ore is processed, these radioactive materials become concentrated in the waste, posing a significant health risk to workers and nearby communities if not managed with extreme care. Furthermore, the chemical sludge left over from processing can leach heavy metals and other pollutants into the soil and groundwater, contaminating drinking water supplies and agricultural land for generations. There are places in the world that have been mining rare earths for decades, and they serve as a sobering reminder of the environmental toll. We've seen images of entire landscapes scarred, rivers turned toxic, and communities facing serious health problems. It's a profound irony, isn't it? The very materials we need to build a clean energy future are obtained through a process that can be incredibly dirty and destructive. This creates a massive paradox for the green movement. We are trying to solve one environmental crisis, climate change, by potentially creating another one, widespread pollution and habitat destruction from mining. So are we just trading one problem for another? Well, it's not that simple, and it's certainly not hopeless. The challenges are real, but so are the solutions being developed by brilliant scientists and engineers around the world. The first, and perhaps most crucial, piece of the puzzle is recycling. Right now, we are terrible at recycling rare earth elements. It's estimated that less than 1% of REs from end-of-life products are ever recovered. Think of all the old phones, laptops, and other electronics that get thrown away. They're a literal treasure trove of these valuable materials, an urban mine just waiting to be tapped. The problem is that it's incredibly difficult. These elements are used in such tiny quantities and are so deeply embedded within complex products that getting them back out is a technical nightmare. But a lot of research is going into developing better recycling methods. Scientists are experimenting with everything from bioleaching, using bacteria to dissolve and separate the metals, to new chemical processes that are cleaner and more efficient than traditional methods. If we can crack the code on large-scale, cost-effective recycling, it would be a game-changer. It would dramatically reduce our reliance on new mining, conserve resources, and cut down on the mountains of electronic waste we produce every year. The second major area of innovation is in finding substitutes. Do we always need rare earth elements, or can we design our way around them? This is a huge focus for researchers. For example, some companies are developing electric motors that don't use rare earth magnets. These might be slightly less efficient or a bit heavier, but as the technology improves, they could become a viable alternative, easing the pressure on elements like neodymium. Similarly, in the world of solar power, while some high-efficiency cells use critical materials, the vast majority of solar panels installed today are based on silicon, which is the second most abundant element in the Earth's crust. Researchers are constantly working to improve the efficiency of these silicon-based cells, which would allow us to generate more power without relying on scarcer materials. The goal is to create technologies that are not only green in their operation, but also in their creation. And finally, we need to get smarter and cleaner about mining itself. There's no getting around the fact that for the foreseeable future, we will still need to mine new materials. But we can do it better. New mining techniques are being developed that have a smaller environmental footprint. In situ leaching, for example, involves pumping a solution underground to dissolve the target minerals and then pumping the solution back to the surface, avoiding the need for massive open-pit mines. And stricter environmental regulations and enforcement are essential to ensure that when mining does happen, the damage is minimized and the waste is handled responsibly. So where does this leave us? The journey to a renewable energy future is more complex than just putting up solar panels and buying electric cars. It forces us to confront some difficult truths about the materials that underpin our technological society. The rare earth element challenge is a perfect example of this. It shows us that there are no simple, magic bullet solutions. But it also shows us the path forward. It's a path that requires a multi-pronged approach. We must aggressively pursue recycling, innovate to find substitutes, and demand cleaner, more responsible mining practices. As consumers, we have a role to play too. Supporting companies that are transparent about their supply chains and investing in sustainable product design is crucial. And simply being aware of this issue, of the hidden story behind our green tech, is the first step. The road ahead is challenging, but it's not a dead end. By combining technological innovation with a strong sense of environmental and social responsibility, we can navigate the paradox of rare earths. We can build a truly sustainable future, one that is not only powered by clean energy but is also built with materials sourced in a way that respects our planet and all its inhabitants. Thanks so much for watching. This is a complex topic, and I'd love to hear your thoughts in the comments below. What do you think is the most promising solution? Let's get a conversation started. And if you found this video insightful, please give it a thumbs up. And don't forget to subscribe and hit that notification bell so you don't miss our next deep dive. See you in the next one.